Assalamu alaikum. Hello everyone and welcome to this presentation on linked list. My name is Ahmadur Rahman and today we will explore the concept of linked list, their types, operation and real world application. Let's dive in. Welcome to this presentation on linked list. Let's start with the outline of today's discussion. First, we will answer the question, what is a linked list? Understanding this fundamental data structure is key to appreciating its application. Next, we will explore why you might choose a linked list over an array. There are specific scenarios where linked lists offer significant advantage. We will then discuss the different types of linked list. This includes singly linked list, double linked list, and circular linked list, each with its unique characteristic and use cases. Following that, we look at the various operations you can perform on linked list. This operation includes insertion, deletion, searching, and traversal. We will also examine some of real-world application of linked list. Understanding this application will help you see the practical value of this data structure. What is a linked list? Linked list is a linear data structure used in computer science to store a collection of elements. Each element is called node and each node contains two parts. One the data contains element, and link. The link contains address of another node. In the diagram below, we can see that each node is linked to the next one, forming a chain like a structure. The first node is called the head and the last node points to null, indicating the ends of the list. This simple structure allows for efficient insertion and deletion of elements. Now that we understand the basics, let's move on why we might choose a linked list over an array. Let's use an example to understand linked lists better. Imagine a chain of paper clips. Each paper clips represent a node and the way they are linked together represent the pointer or link. Just like the paper clips are connected one after another to form a chain, nodes in a linked list are connected using pointers, forming a sequence. This visual can help us grasp the basic structure and connection of node in a linked list. Why linked list over array? That image shows that linked list is a data structure that overcomes the limitation of arrays. Arrays have three main limitations. Fixed size. Once an array is created, it has a fixed size. This means that you cannot add or remove elements from the array. Memory waste. If you allocate more space than you need for an array, you can waste memory. Conversely, if you allocate too little space, you will run out of room and need to create a new larger array. Contiguous memory allocation. Arrays require all of their elements to be stored in contiguous memory location. This can make it difficult to insert or delete elements from the middle of an array. Linked lists do not have this limitation. They are dynamic data structure, which means that they can grow or shrink in size as needed. Linked lists also do not require contiguous memory location. This makes it easier to insert or delete elements from the middle of a linked list. In summary, linked lists are more flexible data structure than array. They are good choice for application where you need to insert or delete elements from the middle of a list or where the size of the list is not known in advance. This image shows the different types of linked list. Let's talk about each one. Single linked list. This is the most common type of linked list. Each element or node in the elements contain data and a reference or pointer to the next node in the list. Think of it as a train with cabooses linked together, but only one way. Double linked list. Similar to a singly linked list, but each node also has a pointer to the previous node in the list. Imagine the train cabooses can connect to each other into two directions. Circular linked list. In a circular linked list, the last node in the list points back to the first node, creating a loop. Imagine the train tracks loop around and connect back to the first caboose. Circular doubly linked list. This type combines the feature of a doubly linked list and a circular linked list. Each node has pointer to the previous and next node and the list is circular. Think of two-way train cars moving on a circular track. Operation on linked list. Let's now look at the common operation performed on linked list. These include insertion, deletion, searching, and traversal. Each of these operations has different time complexities depending on the type of linked list being used. Insertion operation. Insertion in a linked list involves adding a node to the list. This can be done at beginning and or any specific position with the list. The process varies slightly depending on the type of linked list. Algorithm of beginning. There are shown the algorithm of single linked list. Insertion at beginning in single linked list. Algorithm are shown on the picture. Deletion in a linked list involves removing a node from the list. Similar to insertion, this can occur at the beginning and or specific position. Handling pointers correctly is crucial during deletion to maintain the structure of the list. Here is the algorithm of deletion in a single linked list. Firstly, step 1, if head equal to null, write underflow. Go to the 5 end of if. Step 2, set ptr equal to head. Step 3, set ptr equal to head to next. Step 4, free ptr, and step 5, exit. Here is the diagram of deleting a node from the beginning. Here is the algorithm of searching in singly linked list. Here is the diagram to find element in a linked list. Here is a demo program for inserting, deleting, displaying elements using object-oriented programming class. Application of linked list. Linked lists are widely used in various applications such as implementing data structure like stacks and queues, managing dynamic memory allocation, and designing complex data model like adjacency list for graphs. Linked list is used in a wide variety of applications such as polynomial. Linked list is used in a wide variety of applications such as polynomial manipulation representation, addition of long positive integer, representation of space matrix, addition of long positive integer, symbol table creation, mailing list, memory management, linked allocation of files, multiple precision arithmetic, etc. Advantages and disadvantages of linked list. Advantages: dynamic size. They can grow or shrink as needed, no need to predefine size. Efficient insertion and deletion. Adding or removing elements is simpler, no need to shift other elements. Memory efficient. Allocate memory only for used element, unlike array with wasted space. Disadvantage of linked list. Slower random access. Finding a specific element requires traversing the list slower than arrays. Extra memory uses. Each element stores data and a pointer using slightly more memory. Linked lists are flexible for changing data size but slower for finding a specific element compared to arrays. That's all about my presentation on linked list. Thank you so much. Allah Hafiz. আসসালামু আলাইকুম ওয়া রাহমাতুল্লাহ।